So we're going to look at flat rate depreciation, and flat rate depreciation is an arithmetic sequence, and sometimes they use the word linear because that's similar meaning. Okay, so when we look at flat rate depreciation, we can see that a constant amount is subtracted. So instead of adding, we're going to take one away. So we're going to see that recurrence formula looking like this, where we'll have an initial amount, say $100, and then we might see that when we get a recurrence rule or whatever, we'll have the term we have, and we're going to subtract maybe, say, 20. So you'll see the same amount. So this bit is like the constant amount, okay? So that's what an arithmetic depreciation is. So how do you get that amount? So sometimes the amount, when we have flat rate depreciation, the amount is worked out by being a percentage of the initial. So what do we mean by that? The percentage of the VO. Okay, so say $100, if we're minusing 20, we're saying 20% of 100 is going to be taken off every time. All right, so we might just pop some notes in under here. So the recurrence modelling for flat rate depreciation is that you have VO, so that will be your initial amount, initial value. Okay, and then we'll have the official, how you get the formula. It's always going to be Vn, and it will be minus D. Okay, so this is your formula, recurrence formula for flat rate depreciation. So you need to know how to calculate D. So we're going to show you over here. So D will equal your rate. Now I'm going to start writing this PPY, and I'll go over it with you in a minute, and over 100. Okay, so what over here, we're going to say that rate equals the percentage rate per annum, or R, sorry. So what do I mean when I say per annum? Per year, good. So often, if the recurrence formula, if they want you to say monthly, you're going to have to divide that rate by 12 because it's a rate per year. So what I'm going to say, PPY is the amount of times it is, I guess what you're going to say, charged or something per year. So we'll just put a few little examples. So if PPY equals 12 if it's monthly. What about if it is fortnightly? PPY equals what if it was fortnightly? 26, guys? Yeah? You need to probably know this. Sorry, I think I spelled that wrong. All right, so does that make sense? So the PPY is how many times per year, yeah? Paid out per year or whatever. So if it was fortnightly, there's 26 fortnights in a year. So that's what you would do. If they ask you for the monthly formula, what will you divide by? 12. What about weekly? 52. Good. Excellent. All right. So if we just wanted to bring to your attention the flat rate depreciation graph, and it's an arithmetic, and it's the same amount every time. So you see a straight line. So that you're going to see a straight downwards line, aren't you? Yeah, for flat rate. So sometimes they give you a graph and they say what recurrence relation does this model? And if you see a straight line going downwards, you would think that maybe it could be a flat rate one model. Okay, so just down here is a few little formulas on how to find D. So just be careful. We want to make sure you, the rate per annum, you need to make sure you got to divide the rate by PPY if you need to. So if it's just per annum, you can use the per annum rate. But if it was, 12, you'll have to divide that per annum rate by 12. Okay, so let's go on and do... So we remember back with simple interest, this was the recurrence relation, and we can use this to find a term step by step. But if I said, can you find what happens after 28 weeks, you don't want to be sitting on the calculator just going step by step. So we create another one, which is called the nth term rule. So you get asked, and that's what we're going to do now, the nth term rule. Okay, so you will see this wording being said in your questions. Find a rule for Vn or the nth term, so you know you should be looking at this. So let's write out the rule for the nth term for flat rate depreciation, and it will look like, it will look like this. You will have Vn, so the way I find any number in this sequence or this term, it'll be Vn equals VO, so whatever your original amount is, minus n times d. So you worked out before how to find d, and there's n. So if, for example, you had to find 20 weeks, that n becomes 20. So it'd be whatever VO is minus 20 times d, and so on. So let's just write out so we're sure of what that means. So Vn is the value of the asset after, and we're going to say n periods. So it could be yearly, could be monthly, whatever. Okay, and VO is always your initial value. Okay, and then just to recap, so in case you've gone to this part of your book and you want to know what D is, so D is always R divided by PPY, which is the amount per year, divide by 100 because it'll be a percentage, and times by VO. Okay, so if you pop that D into the formula up there. Okay, so let's do a few examples here. A new car was purchased for $24,000 in 2014. So I'm going to start going that's VO, yes? And the car depreciates by 20% off its purchase price per year. So I just want to show you, see how it says off the purchase price? That is an indication to you that is saying it is flat rate depreciation. So it didn't really say using flat rate, did it? But because it's saying off the original price, it's just always going to go down by that same amount. That means it indicates flat rate. So now you've got to remember, when you see off its purchase price, that means it's a flat rate. It's talking about flat rate. Okay, so, and then they've said that it models the depreciating value of this car using the recurrence relation form. So they've been nice and they've shown you what a recurrence relation form is. You probably won't get prompted like that. You'll just have to know what a recurrence relation is. So we know that anyway. So we'll go put our VO in, which was 24,000. And now we're going to go try and find Vn plus 1, which is Vn minus, now I need to find the D. So over here, I'm going to work out the D value. So D equals the rate divided by how many times per year over 100 times VO. So it's just asking me to do a relation form. It didn't say. Let's say that it said yearly. They really should be clearly. So we'll do 20% over 1 times a year times 100 times VO. So 20% of 24,000 would be what? 480? Is it? No, a bit more. 4,080? What is it, boys? Okay, so it's 4,800. So over here, that's what D equals, so I'll put that there. So 4,800. So there I've done a recurrence relation. Using this model, determine the value after 2 years. So when you just get asked to do those short amounts, we'll do it on the calculator like we normally do. So remember, we put in 24,000, press enter, and it comes up here. And remember, if I press minus, remember answer comes up. When it finishes it, you don't see answer, do you? I'll pause it and show you. So it's asked me to find the value after 2 years. So that was 1 year, 2 years. So I'll just write the value was 14,400. Okay. I'm going to keep going to the next. There's probably a few more questions on the next time. Yep. In what year will the car's value depreciate to 0? So you might just keep going on your calculator there. So we'll do that. Okay, so we kept clicking through our calculator and we saw after 5 years. All right, so let's do this next one. The following recurrence relation can be used to model the flat rate depreciation, sorry, that shouldn't be there, of an asset of office furniture. So once again, you should be highlighting that it's flat rate depreciation because you want to go to your formula when you get your summary at the end and go straight to flat rate, yeah? It'll save you a lot of time. Okay, so they've told me what the initial value is, and which is 24,000, and they're showing me how I get the next term. So I'm minusing 1,200 every time. And can you see that this is modelling after years? So right there, they told me this is a yearly formula, so that's good. That's probably what the other questions should have had in them. So what is the initial value of the furniture? So what's the initial value of the furniture? Good. So the furniture equaled 24,000. They're just going to test you on that to see if you think. And how much does the furniture decrease? Yeah, it decreases by 1,200. Good. Okay, write down the rule for the value of the investment after n years. So if you go back to your VN formula, VN was equal to VO minus N times D. Yeah? So if I'm going to substitute what I have in this example, what was VO? 24,000. Now minus, I'm going to leave N there because I'm creating a rule, but what was D? Good. So it will be 12,000 N. So can you see that is the answer there? That's it. You found the nth rule there. Okay, so then use this rule to find the furniture after 6 years. So really they want me to find V6. So I'd go V6 equals 24,000 minus 12,000 times 6. Oh, sorry, I just went too many there, didn't I? Yep, sorry. 12,000 times 6. Don't trust people, that's good. All right, so we got 16,800. And how long does it take? So always start going like this. How long? That means N is the question. Does it take it to the value? So you want Vn to equal 0. So you can pop that into your Vn formula. You can say 0 equals 24,000 minus 1,200 times N. And there's only N in that equation, isn't there? So you can solve it if you like, comma N, and we'll work out how many years it takes. Let's go do that. Okay, I get 20, so it will take 20 years, yeah? 20 years to decrease to 0. All right, this one. So we have a photocopier in the office costs $6,000 when new. They just told me a VO. Okay, its value depreciates at a flat rate, and you're going to highlight that so you know you're using flat rate, and it's a flat rate of 17.5% off its new value each year. So they've pretty much told you the rate there per annum. So that's R there. So what is the value after 4 years? So after 4 years, you might want to just do the nth term formula straight off if you like. So we're going to do that. So I know Vn equals VO minus N times D. Okay, so I'm actually trying to find V4, but let's get our Vn formula first. So Vn equals VO, which is 6,000, minus N times, and I'm going to work out D. So D is always the rate, 17.5, divided by how many, like per year, or so it's 1 over 100 times 6,000, because that's VO, isn't it? So what I just did there, we're remembering that D is R over PPY over 100 times VO. So I just did that bit there. So this bit here is the D. Okay, so we do that and we end up with, and then you want 4. So if you want V4, you're going to do 6,000 minus 4 times that, 17.5 over 100 times 6,000. And you can do that all in one go on your calculator if you wish. And hopefully you end up with 1,800. So what is the value? Just write value equals 1,800. Okay? So here's an example of an exam question, and I just wanted to show you, because this is a graphing question, and I don't think they come up as much in your textbook, but they do in the exam. So just to explain what happens, this here, this was what percentage of the students got it right in this exam. So only 39% got it correct. So that's a very low percentage. When you see anything, when you look at exam reports, and that's a very good study technique to do, when you look at exam reports, anything under, generally under 60, but definitely under 50%, they're probably going to repeat that type of question again. They won't be exactly the same, but they're going to repeat it because they believe that it wasn't taught. That's their sort of theory, that it's not taught. So that you will repeat. So this is why we're looking at this, and I like it because it's a graph question, which you don't seem to get as much in your textbook. All right, so let's have a look at what happens. And it goes, the graph below shows the value, Vn, of an asset as it depreciates over 5 months. All right, so which of the following, when you go down to the question, what's it asking? It says, which of the following depreciation situations could this graph best represent? Now, can you see down here, so it's sort of saying flat rate, unit cost, reducing balance, and they're saying things like that, okay? So we would probably start thinking about, is it a straight line going down or is it a curved? Yeah, because a straight line down will be flat rate or unit cost. And we'll do unit cost in a minute. So can you see here, can you see the drop from here to here? Oh, sorry. Is 1 box. Yes? And can you see here to here is 1 box? So that has dropped by the same amount. So same amount, and that equals either flat rate or unit cost, yes? Because unit cost means it's dropping by the same amount, okay? So at that part of the situation, it's flat rate. Now, all of a sudden, we see a drop of 1, 2, 3, 4, yeah? There's a drop of 4 there. And then let's look at the next thing. So if I go here, I go 1, 2, 3, 4. That's also a drop of 4, yeah? And then I go here, 1, 2, 3, 4. That's also a drop of 4. So that is dropping by same amount. So what is that? Yes, good. by same amount. So that must indicate it is also flat rate. So what happened is just the amount it's dropping for all of a sudden changed, didn't it? So can you see, if I look down at these questions, flat rate depreciation with a decrease in depreciation rate after 2 months. Did the amount decrease or did it get bigger? The amount it dropped increased. So do we have that answer here? Yeah. So we've got that there, don't we? A flat rate increase. So this increase was because the amount got bigger. Okay? So that's the answer. Okay, so unit cost depreciation is still an arithmetic sequence. So still an arithmetic or linear sequence. And it's still dropping by the same amount, okay? But instead of it being the amount being calculated as a percentage, it's just an amount that has been decided. So sometimes they say, if you're using a lawnmower, every time you use that lawnmower, the value of it decreases by $2. So they've worked it out that it's a value that every time you use it, it will reduce. So it's not a time thing, is it? It's a use. So if it sat in the garage and never got used, its value is still good. But if the more it gets used, the value goes down. And that's what the unit cost depreciation is. It looks very similar to flat rate. It's just how the D is calculated. So if we go to write our recurrence relation for this, you will still have VO, which will be your initial amount. So it'll be the initial value of the asset. So it'll be what you bought the machine or the product for. Oh, sorry, I can't spell. You'll get used to that I can't spell. Sorry. Okay, so this is a recurrence relation, so I definitely need to have a Vn plus 1 as well. So Vn plus 1 is actually the same. It'll be Vn minus D, but we're going to calculate the D in a different way. D will equal the cost per use, per unit of use. Okay, so if you had the photocopier, cost you 5 cents every time you use the photocopy machine, it'll decrease. So if you do 100 copies, $5 and so on, So that's what they're talking about. It's still, if you have a look here, it's still a straight line downwards. And you might want to write the same amount drop, yeah? So before, if I'd said that it was a unit cost, but they'd have to say it's a change in the unit cost, and that wouldn't really happen. Normally we say, a machine costs so much to run every use, and that's it. Okay, so once again, we've got to find we've got a recurrence relation for flat unit cost. Now we're going to make an end-term formula, which is the same as the flat rate, but obviously the D is found in a different way. So it'll be N times D, and where D will be the cost per use. All right, so let's do a couple of examples on page. All right, so we have write down a recurrence relation model if the computer was purchased for $18,000 and depreciated at $350 per annum. So I think I've mixed up a few here, but it doesn't matter. So that's my D, yeah? So if I write a recurrence relation, I have to write VO, and I then have to write a Vn plus 1, which I'll write Vn minus, and I'm going to say 350, yeah? Okay, how many years can the computer be used? This is a flat rate. Sorry, I don't know, got shoved in there by accident. How many years can the computer be used before it depreciated? So I just did on the calculator quickly, and you can see I did the 1800. Then I went 1, 2, 3, 4, 5. So, oh, sorry, you had to go just less than $100. So I'll just say 5 years. Okay, that was just another quick flat rate one, sorry. Let's do the unit cost. So a professional gardener purchased a lawnmower for $270. The lawnmower depreciates by in a value by $3.50 each time it's used. So when you see used and by amount, you know that means it's unit cost depreciation. Okay, so hopefully you start looking for those and you'll know it's that word. The model, the depreciation, so they want you to set up a model, a recurrence model for this. So all we have to do is go, all right, VO was 270, then we write the VN plus 1, and we know what the D is. It was what, $3.50, and it'll be times every time we use it, so times N. Okay, and what was the value after 5 uses? You can just quickly do a recurrence because 5 uses, it's 5 times on your calculator is not hard. So I did 270. So there's 1, 2, 3, 4, 5, and I see that it's $252.50. Okay. Going on, they're probably going to ask, no, we've got another one. All right, a hairdryer in a salon was purchased for $850. Oh my God, it must be a Dyson. The value of the hairdryer depreciates by 25 cents for every hour in use, okay? So every hour in use, hopefully unit cost is flagged there. What's wrong with the 25 cents? What should I be changing that to? Excellent. Why are we changing it to 0.25? Yes, excellent. We always work in dollars. We won't have cents. Okay. Let VN be the value of the hairdryer after N hours. So that's good because they gave me an hourly rate. Write down the rule to find the value of the hairdryer after N hours. So can you see we want the nth term rule? There. So the nth term rule is you write VN, it will equal VO. So what was VO? 850 minus the D times N, which is 0.25 times N. Yeah? So we've used the nth term formula. What is the value of the hairdryer after 50 hours? So they really want V50. So V50 would equal 850 minus 0.25 times 50. And work that out. All right, so I'm going back on. So we get $837.50. On average, the salon will use the hairdryer for 17 hours each week. How many weeks will it take for the hairdryer to halve in value? So you want, first of all, what's half the value? Literally, what would be half the value? Good, 425, because you're saying half of 850. So really what you're saying is you want to find when VN equals 425. You want to know N at that case, don't you? So let's use our nth formula. And so I'm going to say 425 equals 850 minus 0.25 N. Good. And I'll do solve. And this is going to tell me how many hours I've used this for. So I end up with N equals 1700. So the hairdryer has been used for 1700 hours when it gets to 425. But so therefore, if they do 17 hours a week, how many would, so then how many weeks would this be? So 17 hours divide by the 17 per week, yeah? So how many days does it get to use it for? Or they've used it for? Or how many weeks, I should say? 100 weeks, yep. Okay.